Okay, welcome everyone. We're going to be talking about alkali metals for this screencast. So I've written some notes down, just follow my pen and yeah, let's get straight into it. So the alkali metals are a group of elements. Remember, a group is just like a column going downwards like this. And here they are. We've got lithium, we've got sodium, we've got potassium, rubidium, caesium and francium. Okay, these are all the alkali metals. You get different names of groups of elements like the halogens and the noble gases. These are called the alkali metals. Now, alkali metals are interesting because they're kind of sort of natural occurring metals in the environment. And what happens with these metals is they can react with water. Okay, so let's take one of these metals like sodium. Okay, you can physically actually take a piece of sodium metal and you can put it into water, and what will happen is it will make a alkali. Okay, so this is sodium hydroxide, which is a very strong alkali. It is right, if you had look at the pH scale, 1, 2, 3, 4, all the way up to 14. Sodium hydroxide will be around this region. It'll be blue if you had to use universal indicator, which is sort of just a piece of paper that indicates whether something's an acid or a base. Another word for base is just alkali. So the reason why they're called alkali metals is because they form alkalis, like sodium hydroxide. You could also just take potassium, chuck it into water, and you'd also make a pretty strong base, potassium hydroxide. And you always form hydrogen gas. And if they ask you a question in the exam, what do you observe? You can say you observe bubbling or fizzing from the hydrogen gas being released from this chemical reaction over here. Okay, so it's a bit messy, but that's the sort of introduction to alkali metals. Okay, let's go into the properties of these. Now you need to know both let's do some red. You need to know physical properties. Okay, what do they actually look and feel like? And then the chemical properties, in other words, what happens in a chemical reaction. So let's go on to talk about the physical properties first. They're soft. Okay, they're quite soft metals. So I got a picture here. Here is some, I think this is sodium, and the reason why this person's wearing gloves is because there's enough water in your sweat to actually cause a reaction between sodium and the water on your hand. And what that'll do is it'll really burn your hand, because if you go back and look at the product that's formed, you know, you've got sodium and you've got the water on your hand, it forms the sodium hydroxide, and this is an incredibly strong base. And if something's either a strong base or a strong acid, it can be corrosive. Okay, it can eat away at certain things. And if you've ever picked up some of your jick lying at the bottom of a sink cupboard and you spill some on your hand, it will be quite an irritant for your skin. Your skin will go red. So properties: soft. And that's what we can see, and then we went on a little tangent there, but it's fine. Okay, so the physical properties is, if you had a look at the boiling points of these alkali metals in this group over here, the boiling points generally get lower and lower as you go down. So let's come up with a random boiling point of lithium. Let's say, I don't know, 1,000 degrees, right? If you go downwards, the boiling points will then decrease. So these are not the correct boiling points, but just to show you a physical property is that the boiling points and the melting points, they decrease the further down you go in terms of the group. What's quite interesting is that the further down you go, the density increases. Okay, so if you had a look at the density of lithium and sodium, these things would float on water, but if you had francium, it wouldn't, because it's much more dense. Okay, so that's something that I'd like to mention. Cool. So What does this mean, no change in comp? This means that I haven't changed the composition. All right, I've just got sodium as is. It is a solid. If I represented it in an equation, I put the state symbol as a solid. This is what it would be. Okay, in a chemical reaction, the chemical composition obviously changes, and that is a classic example would be to put it into water. You would change the composition. It would change into sodium hydroxide and H2O. This is not a balanced equation. It's balanced now with 4 hydrogens, 2 oxygens, 2 sodiums. There we go. So yeah, in a chemical reaction, the composition changes. But let's go and talk about more chemical reactions. So something that you might come across in this topic is that these alkali metals are called a family of elements. And this reason why they're called this is because all of them share one chemical property. Now, one chemical property is this wonderful thing over here. Let's get the highlighter out. I wonder if I can change the color. I like yellow. Yellow, there we go. So this thing over here, what is that thing called? It's called the electron that is in the outermost shell. It's otherwise known as the valence electron, outermost shell, and all the group 1 alkali metals, they all only have 1 electron in the outermost shell. And this is why they are called not only the family of elements, but why they share similar chemical properties. So let's have a look. Okay, chemical properties. They react with water to form a hydroxide. We saw that. Lithium hydroxide, sodium hydroxide, potassium hydroxide, anything with this OH is hydroxide. Okay, another thing is that they can react with oxygen to form an oxide. So, for example, sodium oxide. So if you just had a random piece of metal, sodium metal, and you actually exposed it to the air, it would cause a chemical reaction to take. You'd have sodium oxide. And remember, when we talked about iron, I think a few weeks ago, we had this concept of iron oxide, which is otherwise known as rust. So when we form these oxides, in fact, this sodium, if you had to sort of expose it to the air, eventually, I'm not entirely sure what the color is, but let's just say it looks like rust. Eventually, this sodium will start to degrade away as it turns into sodium oxide. Okay, and this happens for all the group 1 alkali metals. Okay, they react with the halogens, another group, to form these salts like sodium chloride or lithium chloride or potassium chloride. Okay, and they form ionic compounds, which is another chemical property. Remember, ionic compounds like sodium chloride, if we had to put this into water, it will dissociate into ions, sodium and chloride. Okay, so all the properties of the alkaline metals. Okay, let's get into some more sort of deeper stuff now, and let's go and look at this reaction with water. Now, of course, you can go and look at some videos that are available on the online campus, but they're also available as part of your notes, and you can actually go and look at the reactions of some of these alkali metals with water, and they're really fascinating because they're vigorous, they're like explosive, and they're really quite wonderful to watch, but quite dangerous as well. Okay, so let's say we had a piece of sodium over here. Okay, let's just give it a nice little border so you know where I'm. Okay, so here's your piece of sodium, right? And generally what happens is in a chemical lab, we won't just have sodium lying around. And let me ask you the question, why wouldn't you just have sodium sitting in a cupboard just sort of exposed by itself? Let's see if you get the answer. Did you get that? Well, it will react with oxygen in the air and form sodium oxide, and it will degrade. Okay, so generally speaking, in a lab, you will have a piece of sodium, okay, and you'll have kind of like a I'm going to draw this in green, but you'll have like an oil, okay, that surrounds the sodium, that's to protect it from being exposed to the air. So if you took this out, like let's say you had a pair of, it won't let me do tweezers, okay, there, say you had some tweezers here. Oh, I can't really do tweezers. You can imagine just sort of picking that up, and if you had to plop it into this water, what would you observe? And this is a classic question in the exam. Remember, when you say when the question says what do you observe, you must write very key words like fizzing. Okay, you're going to see some fizzing, and what is the result? Not the result. Why does it fizz? And this is because H2 gas is coming off. So H2 gas from the sodium plus the water. Remember, there's the hydrogen gas is part of the water. So it forms sodium hydroxide, metal hydroxide plus H2. So you got these tiny sort of H2 bubbles coming off very randomly, and they're sort of spitting off or fizzing off the water. Now, it's quite random how they do this. So sometimes it will be sort of more dominant on the left hand side. So you can imagine if like a whole bunch of gas was coming off of the left hand side, which direction would the ball go? Quite right, it would probably move to the right, and then it sometimes sort of goes to the right, and so what you'll observe is that this ball will sort of be traveling from left to right within this beaker of water. So that's one observation that you can make. Of course, what is going to happen is the sodium hydroxide is going to start to form, and what sort of you start to see this sort of like white trail of sodium hydroxide that obviously dissolves in the water and forms these ions, sodium and the hydroxide ions, and so you'll observe that for sure. And then if you had to take sort of universal indicator paper, which is generally this like strip of paper, and you sort of touched it against this water, this paper would then turn, you guessed it, what color? It would turn like a bluish, even like a darker sort of like purplish color, proving that the pH of this is very high, proving that sodium does then make an alkali as one of the products. Okay, so that's the reactions with water, and this happens obviously for all the other alkalis. But if we go back to the top of our page, you'll see that, and you'll see this from the videos as well. Okay, let's just get rid of some of this stuff here. So we used sodium there, right? Like, so there's sodium. If you had to use potassium, you'd see even more vigorous activity. In other words, the ball would be spinning around even faster and faster and faster. And then rubidium, if you had to use any of these three, in fact, I think there'd just be a massive explosion, and that's because of all the hydrogen gas building up and completely exploding. So yeah, if you think about this, as we go down, we say in the exams, the reactivity increases. Okay, and we're gonna talk about that in another video of the reasons why it has such a vigorous reaction. If you do want to go and enrich yourself a bit further, you can go and research that yourself. Type in why does sodium react with water the way it does. Okay, reactions with air. Okay, so as I've said before, we have lithium, sodium, potassium. Generally, these are the three that we have in a lab, and they're stored in oil. Okay, and that's to prevent them from reacting with the oxygen. So that's pretty much everything that we're gonna kind of talk about in this series. I was going to talk about some stuff with the Bunsen burner, but let's leave it there for now, guys. I hope it's been I really just need to rub this out because I'm just a bit OCD like that. Okay, I think that's been quite sort of helpful, and I'll see you in the next screencast. Lovely, guys.